The last question involved the displacement of water. We've got CaCO3 limestone decomposed to a solid calcium oxide and carbon dioxide gas when heated at high temperature. So at temperature 30 degrees Celsius, you've got a volume of 107.3 ml of carbon dioxide gas collected by displacement of water. Okay, please highlight this word with a total pressure of 1 atm. So calculate first the number of moles of carbon dioxide and the mass of limestone decomposed. So this is our figure or picture for the displacement of water process. So imagine that we've got limestone CaCO3 at here. So the CaCO3 will decompose to form a product of calcium oxide plus carbon dioxide. So these green dots represent the carbon dioxide gas being released into the vessel, into the water in here, and then into the trapped air. Alright, so first to find the number of moles of carbon dioxide. Okay, please be note that we are talking about the displacement of water. So basically, we're just gonna be using this equation only. Okay, so does it has mole in the formula? No, right? So the only way that you can calculate the mole is by using the ideal gas equation. Okay, remember when I said that all gases involved in Dalton's law equation are ideal gas. Okay, so we can be using PV equal to nRT. Okay, again, volume must be total. Mole, we want to find the mole of carbon dioxide. Okay, so the pressure must be pressure of carbon dioxide and your temperature. Okay, well, usually the question will only give you one temperature, so just use that. Okay. So before using this ideal gas equation, so let's figure out what information do we have. So we've got temperature of 30 degrees Celsius, which need to be converted to Kelvin, which is going to be 303 Kelvin, and a volume of 107.3 ml need to be converted to liter. So it's going to be 0.1073, and the total pressure of 1 atm. Okay, please, class, please be note that we've got the pressure of water, which is 318 millimeter per mercury. Millimeter mercury. So the pressure of water is 31.8 millimeter mercury. So we need to convert this to atm. Okay, so it's gonna be 31.8 divided by 760 millimeter mercury. So it's gonna be 0.04184 atm. Okay, just convert everything into the respective unit of ideal gas equation. So rearrange your ideal gas equation. So the mole must become the heading. So mole is equal to pressure of CO2 times the volume total divided by RT. Okay, so check what information that you have yet. Do I have the pressure of CO2? No. The volume? Yes. R? Yes. T? Yes. Okay, we just need to find the pressure of CO2. So pressure of CO2. So refer back to your Dalton's law formula of displacement of water. So pressure total is the sum of the pressure gas and water. So pressure total is the sum of your pressure gas plus pressure of water. Okay, so your pressure of CO2 must be 1 minus 0.04184. So that would be 0.9582 atm. Okay, now substitute your pressure of CO2 in here. So 0.9582 times the volume total would be 0.1073 divided by 0.08206 times 303. So that would be 4.135 times 10 to the power of minus 3 mole. So your mole of CO2 is this. Second question is to find the mass of limestone decomposed. So second question is to find the mass of CaCO3. So we're going to use the formula mass equals to mole time the molar mass. Do we have the mole of CaCO3 yet? No. Do we have the molar mass? Yes, we can calculate it. So we don't have any information on the calcium carbonate, but we've got the mole of CO2, which is 4.135 times 10 to the power of minus 3 mole. So you just need to make a ratio based on the equation to find the mole of CaCO3. So 1 mole of CO2 is equivalent to 1 mole of CaCO3. But class, before that, please make sure that you've already write a balance equation. Okay, so this is, I've already checked this before, so we can just proceed to the ratio. So 4.135 times 10 to the power of minus 3 moles CO2 would be the same mole for CaCO3. So your mass of CaCO3 would be 4.135 times 10 to the power of minus 3 mole times with 100.1 gram per mole. So your mass will be 0.414 gram. So that's all for the displacement of water question. Okay, please be note that this formula must be used when the question involves displacement of water. Okay, for the rest of it, you can consider of using the ideal gas equation.